Good grief. Dr. Jennifer Doudna, who I've had on this show before. And she sent a question for you. So I'm going to read this question from Dr. Doudna. Okay. So she says, CRISPR, the gene editing technology that she pioneered, can now target nearly any DNA sequence. But for most genetic diseases, we still don't fully understand which changes in the DNA are actually driving the problem, especially in the 98% of the genome that doesn't code for proteins. With tools like AlphaGenome starting to decode that 98%, how close do you think we are to the moment where AI can reliably point to the exact genetic change causing a patient's disease so that technologies like CRISPR can fix it?
Yeah, what an awesome question. So, I've discussed this with her actually in the past, and it is really exciting. I think with AlphaGenome, which is exactly that kind of technology, it takes the big, long genetic sequences, and then it tries to predict, if you have made a mutation to this particular single letter, single position in the genetic sequence, will that be a harmful, mutation that might cause disease, or is it benign and it won't do anything? And AlphaGenome, which we just released, is the best system in the world for predicting that. So that's exactly what you then want if it got, it's still not probably good enough yet, but you can imagine a future version of AlphaGenomes that are accurate enough to sort of really know, like, oh, that particular mutation in combination with this other one. That's the hard part, is what if they're multigenic diseases where there's cascades of mutations cause the problem? Those are even harder to detect, but actually perfect for sort of AI to try and help with. Then you could go in with something like CRISPR maybe one day and go in and fix that mutation and then fix the problem. So that would be a kind of combination of things like AlphaGenome and CRISPR could be incredibly powerful.